Alright guys, today we're going to be looking at determining dependency. Now, we've already started talking a little bit about functions, right? We've talked about the fact that there's an x and an f of x, or an x and a y. And so what we're going to talk about today is how to decide which of two things is x and which is y, and what exactly it means that they're in that specific position. Alright, so let's go ahead from here and let's look at some terminology first, because this is going to be important as we talk about the dependency. So first, let's define a variable. A variable is a factor or a condition that's subject to change. So it can be anything, right? It can be a height, it can be time, it can be color, it can be, anything that's able to change in a given situation will be a variable. Now you have to be careful, because in some situations they will give you specific information. All right, for example, they will give you that you have a specific cup that is sitting on the table. Now, if you have a specific cup, then the volume of that cup is not going to change. The material that that cup is made out of is not going to change. But what could change would be the amount of water that's inside the cup. Or, that you could come up with some other things, but you have to make sure that the variable is something in the situation that is having the ability to change. All right? Now, in most situations in math, we will have two variables, at least at this level. The first one is called the independent variable. Now, this is what we always put on the x-axis, the horizontal axis. This is the variable that causes a change in another variable. So as I change this, something else will change. Now, like I say, sometimes you have power to change this variable, but sometimes we're just observing it. Right? For example, if x is time, you might not have the ability to make time go forward and backwards, but you can watch what happens as a result of time passing. Okay, sometimes you will have power over it. You might have power over how many hamburgers you're eating relative to how much you weigh, or something like that. So sometimes you'll have power over x, and sometimes you won't. All right, next is the dependent variable. Now this is the y, or the f of x. This is a variable whose value depends on that of another variable or factor. So this is the one that depends on x. As x changes, it causes a change in y, our dependent variable. So let's go ahead and look at a couple of examples. We've got a pot. This is a specific pot that's sitting on a specific stove that's on a specific heat setting. Those things are not going to change. But this is what is given to us. We're looking at the temperature of water on a heated stove rising each minute. Okay, so from this, what are the two things that are changing? What are the two variables? Now, hopefully you say, well, the temperature of the water is going to change. Now, what else is changing? Well, from the statement, it's the fact that the minutes are passing, right? And so time, or you could write minutes. But time is the other thing that's changing. It's progressing. When I first put the pot on the stove, 0 time has passed. After a minute, 1 minute has passed, then 2 minutes, then 3 minutes. So time is changing as the temperature of water is also changing. Now, the next question is, which of those is the dependent variable? It's often easiest to look at the dependent variable first. So what depends on the other thing? Does time depend on the temperature? Or does the temperature of the water depend on how long, the amount of time that you're on the stove? Well, hopefully you figured out that the temperature of the water depends on how long your pot is on the stove. You can't change time just by changing the temperature of the water. I can't just say, okay, well, let's throw some ice in and make the temperature go down, therefore cause time to go backwards. That just doesn't make sense. And so as time progresses, the temperature of the water is changing. And it works if you take it off the stove too, because as soon as you take the pot off the stove, the temperature starts to go down as time progresses. All right? Last of all, which is the independent variable, and that has to be the other variable, which then is time. Time is the thing that's causing a change in the other. All right? Now, this right here is a graph that shows exactly what happens when you heat up a pot. Now, let's answer a couple of questions. All right? First, let's say, what temperature did the water start at? Now, this may not be very clear, but the temperature is in degrees Celsius, and it's going by tens, 10, 20, 30, 40, 50, 60. So I'm sorry it's not very clear, but you can see that the temperature started, so at time 0, the temperature was about 28. Now, we can write that like this. We can say the temperature, or the function of 0 equals 28 degrees. Now, remember, this is the f of x equals y, right? So x is what's being replaced. So I'm putting 0 in for x, 0 in for the time, and the result is 28. All right, well, how about try this one? What is f of 20? Again, since the 20 is in the parentheses, replacing the x, that means we're looking for 20 on the x-axis, 20 minutes. Now, the easiest way to do this is just kind of draw a little line here that goes up to your graph. And then once you've got that point, then come over here, and that's more or less straight, so about 67, 68. So I'm going to go ahead and put about 68 degrees. All right, now let me ask you another question. What's the hottest that the water gets? Well, that we can observe just by looking at the graph, right? We can see that the graph goes up here right to 100. Does that make sense? Well, yeah, of course, because the water's only going to get to 100 degrees, and then it's going to turn into steam, and then you're going to have a little bit harder time measuring the temperature with a thermometer or whatever. I mean, can it be done? Yes, but not just straight up. Let me ask you another question then. What would this be? F of x equals 40 degrees. Now recognize that 40 is f of x, so that's the y value. Okay, so this is asking what is x. So we would go to 40 on the y-axis, and we would go la 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 la, and then we would go down from there. Oops, oops, oh, it doesn't like me. Go away. Okay, there we go. And so it looks like it's about 12.5 minutes. So x equals 12.5 minutes. All right, so we're kind of starting to put this idea of function notation with our understanding and interpreting of graphs. Let's look at another one so we can do a little bit more dependency. All right, here we go. Ball is bouncing up and down off the floor. I have a specific ball that's bouncing on a specific floor. So the ball is not going to change. What it's made of is not going to change. The ground is not going to change. Gravity is not going to change. So none of those things can be a variable. Those things are all constant and consistent. So they're not variables. But, therefore, what are the two variables? What are the things that are changing? Well, hopefully you say, well, the height of the ball is changing, right? Not the maximum height, but the height of the ball. As it's going down, at one point it's up here. At another point it's right here. At another point it's down here. And so the height is continuously changing as it's going up and down and up and down. All right? What's the other thing that's changing? Well, the time, right? Time is passing. All right, so we've got time passing, we've got the height of the ball changing. So which of those is dependent? Well, again, you can't change time just by changing the height of the ball. But as time progresses, the height of the ball will change. And so the height, height of the ball, sorry, the height of the ball is what is the dependent variable. And the independent, hopefully you got, was then time. So let's go ahead and look at what you just saw, which is the next graph. Now this is actually a ball bouncing. Now in this case it's starting at the ground and bouncing up, and then down, and then up, and then down, and then up. And you notice that as time progresses, this is a little more realistic, because as time progresses, it's bouncing less and less and less and less. So let me ask you, what's the highest that the ball goes? Well, it goes up to 4, right? And it doesn't have units here, but let's just say maybe it's feet. So 4 feet is the highest that it goes. Okay? How many times does the ball bounce in the first 5 seconds? Well, let's see if we can find where 5 seconds is. There's 2, 4, so it looks like every 2 is 1. So 1, 2, 3, 4, 5. So there's 5 seconds. How many times does it bounce? There's 1 bounce, 2 bounces, 3 bounces, 4, 5, 6. 6 bounces in 5 seconds. So this is interpretation. We're trying to figure out what's happening. All right? Now, as we look at this, you could do a similar thing as we did before. You can say, well, what is f of 3? Now, what exactly does that mean? Well, the 3 has replaced the x, right? Because that's f of x. And so the 3 has replaced the x, so we'll go to 3 on the x-axis, and then we'll go up, and we'll say, oh, it looks like it's about 2.2. So 2.2 meters. So this, even though it looks very mathematical, actually is just saying, what is the height when time is 3? All right? Easy. Easy, cheesy, peasy. All right. Now, let's look at this one. Michelle and Alice are studying, so they'll do well on the celebration. Okay, well, what are the variables? What are the things that can change here? All right? Well, we could have the amount that they study, right? And what else? Well, they want to do well on the celebration, so their score on the celebration is the other thing that could change. All right, so which of these is dependent and which is independent? Well, hopefully you got that the dependent variable is the score, because the score definitely depends on how long they study. All right, so there you go. Cake, right? No problem. So here is a graph that shows study time on a chemistry test and the grade. Now, a couple of things I want to look at. First of all, is this a function? Is it a function? Okay, well, you've had enough time to think about it and look at it. The answer is no. Why is it not a function? Well, the definition of function is that for each input, for each x value, there's only one y value. You'll notice right here at 3 hours, there are 2 points. All right? That means that for an input of 3 hours, I have 2 possible scores, which means that no, it's not a function. Okay, can we still get information from this relation? Yes, we definitely can, but it's no longer a function. All right? Now, let's consider a couple of things. Let's say f of 5. What does that mean? Well, in terms of this graph, f of 5, since 5 is replacing x, means what is the function of 5 hours, or what will the result of 5 hours of study be? And so here's 5, and I look at it, and it looks like the result of 5 is that I get a, 90%. All right, how about this one? What does this mean? Don't just tell me, well, that means f of x equals 80. Yeah, I get that. I can read that. What does it mean, though? Well, this is saying, what does x have to be? How much study time, right? X is the study time, will result in getting an 80%. Well, so we say, all right, where's my 80%? Here it is. We go, 4. So 4 hours. So F of 4 equals 80%. If you study 4 hours, you'll get an 80%. All right. So hopefully that kind of makes sense. You put things together, and let's do one last one. All right. Now this one's a little bit different. I want you to pause the video when I say now, and I would like you to pause the video and try to come up with what this graph should be representing. All right. Now. Okay. So now you're playing the video again. What could this be representing? Well, it could be any number of things as long as you're looking at the X, which is the months of the year, and then talking about something that depends on this. When we did this in my class, people came up with maybe it was measuring rainfall, though if it's rainfall, I sure hope that's in like millimeters or something. They said, well, maybe actually even millimeters. That would be 25 meters of rain. That's quite a bit of rain there, so hopefully it's not that. Somebody said, oh well, maybe it's like a vacation spot, and so in the summer more people are going on vacation or something like that. Some people, any number of things. What this actually is, the data that I used to create it was a ice cream store, and so obviously during the warmer months they sell more ice cream. All right, so throughout the year, Baskin-Robbins sells ice cream. What are the two variables? Well, if we think about the graph that we just looked at, we had on the bottom scale the months of the year, and then on the y-axis it was the number of ice cream sold. What's the dependent and what's the independent? Well, the dependent is ice cream sold, and the independent is the months. Because whatever month it is will help determine how many ice creams you sell. Now, keep in mind that that's because of the weather. So yes, technically it's the weather that's causing a change, but the weather is directly linked to the months. And so therefore, there's your answer. And that's all. Hopefully that gives you a little bit of a brush up on dependency and a little bit with the function notation and interpreting graphs all at the same time. All right? That's all for now.